Okay, so like we had in the homework last night, you're going to be given a set of data and asked not only to choose the model, which is all the homework asked you to do last night, but actually make the model and then use that model to make a prediction. Once you've got your equation, plug in a value and see what you get. There are steps to this. If you think normally during the test, I have formula sheets. I think I've given you these in the last test, maybe, to make sure you had the quadratic formula. But I also have here calculator instructions, like the common things we do in a calculator if you need to know. That can help to remind you too. So I'll hand those out. And let's see if I can knock this out. There's going to be a question like that table that we had, right, where there was 4 columns. One was for the initial investment, one was for interest rate, one was for time to double, and one was for the amount in 10 years. And then you'll be given 2 of those, asked to find the other. If you remember, the kind when you had to calculate the R, and then you could do the last calculation, it'll be a 2-step kind of thing. Right? And the 15, solve an exponential word problem, meaning, we already did, I showed almost the same problem at the very beginning of these slides, where all you have to do is evaluate the function by plugging in for t. But what if you're given the p and you got to solve for t? That's what I mean by an exponential word problem. Right? You'll be given a value to plug in and then find t. And then the last thing is just know your properties. Right? Know things like that the log, any base of 1 is 0. Remember why that is. Convert it to an exponential. A to the 0 is 1. Anything to the 0 power is 1. We know that. Well, that means log of 1, no matter what the a is 0. Right? The log base a of an exponential, which also has a base of an a, right, has an answer. It all simplifies to whatever is the exponent. Because if you remember, that's like taking f of f minus 1 or f minus 1 of f. When you take a composition of a function and its inverse, they cancel each other out, and all you get is the variable inside the function, or in this case, the exponent, which is exactly why on the middle one, right, the log base a of a to the first is 1. And then one last property, which we dealt with many times, but it was listed as a property, is just the 1-to-1. Remember, if you have the log, you have an equation which equates the log on both sides, it's the same log, then it must be that what's inside the logarithm is equal. That's a property, 1-to-1, which we use to solve equations.